How many subsets of this following set contain at least one prime number? So this problem can be done very quickly if you know that the number of subsets of that set is just 2 to the power of the number of elements in the set. So in this case, the total number of subsets is 2 to the 8th, and you can quickly find the answer. The answer isn't 2 to the 8th, but using that info, you can quickly find the answer. I'm going to go through a solution that doesn't use that information. I'm going to look at this through finding combinations. So first, I want to just look at every single possibility. So let's look at the possibility of just a subset of size 1. So those are all the different combinations of a subset of size 1. In order to find the number of prime subsets, I'm going to subtract, since there are 4 prime numbers in that set, and there are 4 composite numbers. I'll label them here. So 4 is composite, 6 is composite, 8 is composite, 9 is composite. I'm going to subtract off the number of composite subsets so that we're not over counting. So that is the size of the number of ways you can make one subsets of size 1 that are prime. And I'm going to just keep doing that. So I'm going to add 8, choose 2. This is for subsets of size 2. And again, so I don't overcount, I have to subtract the number of composite subsets of size 2. Again, 8, choose 3, total number of subsets of size 3. And again, I have to subtract the number of composite subsets. Again, 8, choose 4. And so again, I'm going to subtract 4, choose 4. And now when I get to 8, choose 5, that's going to guarantee that I have at least one prime number in that subset, because even if I use up all the composite numbers, I use 4, I then have to have a prime number in there. So 8, choose 5, subsets of size 5 will always have a prime number. And the same goes for subsets of size 6, 7, and of size 8. So doing this out will give us our answer. And remember that n choose k is just equal to n factorial over k factorial times n minus k factorial. So doing this all out, I've got 8 factorial over 7 factorial. This is going to be 4 factorial over 3 factorial, 8 factorial over 2 factorial times 6 factorial, 4 factorial over 2. This will be 4 factorial, 3 factorial. This will be 8 factorial times 4 factorial, 4 factorial. 4 choose 4 is just 1. 8 choose 5 is going to be 8 factorial over 5 factorial, 3 factorial. This will be 8 factorial over 6 factorial, 2 factorial. And then we're getting to the end here. This is 8 factorial over 7 factorial, and this is 1. So I'm going to do all those out. Again, adding this. Okay, so doing all this math, I'm going to get 8 factorial over 7 factorial is going to be 8. This is going to be minus 4. This one's going to be 28. 4 factorial over 2 factorial, 2 factorial is going to be 6. That one is going to be 56. 4 factorial over 3 factorial is 4. 8 factorial over 4 factorial times 4 factorial is equal to 70. Subtract 1. And then again, I've already computed 8 factorial over 5 factorial times 3 factorial. So that is 56 plus, found that, that's 28. And 8 factorial over 7 factorial, that is 8 plus 1. Okay. So if I add all of that together, that is going to be, if I add all the positive numbers together, I'm going to get 255. Add all the negatives, minus 15, so I get 240. And that is the answer. So it is D. You can make 240 subsets that contain at least one prime number.